In this video, we're going to talk about exponents and radicals. So we have three different types of problems. We're going to do two examples of each, so 6 problems in all. So the math really is pretty easy. It's just a question of whether or not you know what steps to take here. Okay, so when we have x to the 5th times x to the 4th divided by x squared. So we need to be able to know what to do when we multiply exponents as well as when we divide them. Okay, so when we have the base is the same, right? So here we have x, this is a base, x, this is a base, they're exactly the same. Well, as long as they're the same, then we just add the exponents, right? So 5 plus 4 is 9, and so we have x to the 9th, x squared stays the same down here. Terrible x, there's x squared. Okay, so now we have x to the 9th divided by x squared. Okay, and so when we're dividing exponents, we subtract them. So we're just going 9 minus 2, and we get x to the 7th for our answer. Okay, so again, when base is the same, add the exponents. When we're dividing, subtract exponents. Okay, let's do another one. Okay, so we'll have like x squared times x to the 5th. You know, really we're just changing these exponent numbers, but really everything else is going to be exactly the same in this problem. X squared times x to the 5th divided by x to the 4th. Okay, so again, bases are the same, so we're just going to add these exponents, right? So we get x to the 7th divided by, we didn't change anything down in the denominator, down at the bottom. So then we have still x to the 4th, right? And then we're just dividing exponents, right? And again, all we're going to do here when we divide exponents is subtract. And we got ourselves 7 minus 4 is 3. And so we got x to the 3rd. Okay, so that's the first type of problem. Base is the same. We're multiplying them, add those exponents. When we're dividing exponents, we subtract the exponent. That's all you got to know for that type of problem. Pretty simple. Okay, next style, negative exponents. Okay, these can throw people. All right, so we have 2 to the negative 2. How do we do that? Okay, so really we're doing the inverse of, so if you just saw 2 squared is 2 times 2, and then we'd have 4, right? Okay, so this is really, that would be 4 and 4 over 1 are really the same thing. 4 over 1 equals 4. Okay, and then we're just doing the inverse, right? So now the 4 is on the bottom, the 1 on the top. Okay, that's really all there is to it. And you want to see another one? 4 to the negative 2. Okay, so if we have 4 to the negative 2, right? If we had 4 squared, that would be 16. Yes, 4 times 4 is 16. All right, so this time 16 is on the bottom, 1 is on the top. So that's really all there is to it, right? 5 to the negative 2, we'd have 1 over 25 for the answer, right? So that's all you're really doing. Pretty easy, actually, right? They look confusing when we see negative exponents, and sometimes it's hard to imagine this stuff as far as what the actual answers are, some of these algebra concepts. But that's all we're doing. Okay, last one. We're back to multiplying exponents. So sometimes it'll look like this. So we have x to the 3rd to the 4th. Okay, so in this case, this is different than what we had before. Right, so if you kind of compared them, right, here's 2 different things. You could have x to the 3rd to the 4th, and that's going to be different though than what I'm going to write down here, which is x to the 3rd times x to the 4th. These are not the same thing. It's important to know the difference, otherwise you'll probably get the wrong answer. All right, so x to the 3rd to the 4th, when you see something like this, then you're multiplying the exponents, right? And that'll give us x to the 12th, right? Because 3 times 4 is 12. But down here, x to the third times x to the fourth, which is what we did on the first two problems, then we're adding these exponents. 3 plus 4 is 7, and we get x to the seventh, right? So those are really two different types of problems. Just to do one more here, just we do two of each kind, right? So if we had x squared to the sixth, that would equal, right? So this one is the same as this problem was up here, right? And there we multiply the exponents. So when you see them right next to each other like this, you got to multiply them, and we get x to the 12th, right? Where if it was x squared times x to the sixth, kind of similar to this style right here, x squared times x to the sixth, then we would add them and get x to the eighth. So that's the big difference.